Good morning, students. So in our last class we discussed about the adjoint of a matrix as well as the singular matrix, non-singular matrix, and some theorems that we discussed here, isn't it? So here one more theorem remain here, and this theorem is very important. This one is theorem number 4. If you see the theorem number 4 here, the theorem is given like in this way, theorem number 4. And here, first of all, if we consider a square matrix, remember in case of determinant, always we consider a square matrix, isn't it? So if we consider a square matrix, suppose A, and this square matrix A is said to be invertible. Remember, this one is invertible. The condition is what? If and only if A is what? A is non-singular. A is non-singular. This one is very important point here. So what is the meaning of non-singular? The non-singular meaning is the determinant of A is not equal with 0, isn't it? So if I repeat this one, A is a square matrix. Remember, A is a square matrix, and this square matrix is said to be invertible if and only if A is non-singular. Non-singular means determinant of A value is not equal to 0. So invertible. So obviously invertible means what? A inverse, isn't it? So now here A inverse, there is a formula for this invertible to how to find out A inverse of a matrix. So the formula is like this: A inverse equal to 1 by determinant of A into this one is adjoint of A. This one is the formula. Is it clear? This one is the formula. So A inverse equal to 1 by determinant of A into adjoint of A. So this one is known as invertible. So when we have to find out inverse, so obviously we have to apply this formula. So adjoint of A, all of you know how to find out, as well as determinant of A also we know how to find out. And the main condition is what? This A is non-singular. That means determinant of A value is not equal to 0. If determinant of A value is equal to 0, then it is known as singular. And singular, if we get singular, then what we have to write? The matrix is not invertible. In this way we have to write. Is it clear? Okay, which related to this. Now let's take an example. Now let's see this example. And here the example is given like in this way: if A equals to 1 3 3, first row 1 4 3 1 3 4, and what you have to do, we have to verify this result. A into adjoint of A, first of all we have to find out, equals to determinant of A into I. We need to prove this one. So that means left hand side equal to right hand side we need to prove, and with related to this we have to find out A inverse. So already we discussed what is the formula of A inverse: 1 by determinant of A into adjoint of A. So that means determinant of A we have to find out adjoint of A. So before this A inverse, first of all we have to verify this one. And for this result, first of all what we need? We need adjoint of A, we need determinant of A. So at first we have to find out determinant of A, because if the determinant of A value is equals to 0, then it is not invertible, then we can find out A inverse. Only for that reason, first of all we have to find out determinant of A. So when you have to find out determinant of A here, so now first of all, so determinant of A, so determinant of A means A matrix is already given. So here we have to write this one is 1 3 3, and this one we write 1 4 3, and last one is 1 3 4. Now we have to evaluate this result. So if we evaluate this result, how can we take this one? So this element, if we consider first row first element, so here the position of this element is what? A11. So that means first row first element. There is a technique to write this one. So in this case, first row first element, so that's why here we have to write minus 1 to the power 1 plus of 1. And if we consider this element number, this one is 1, and with related to this, the first row and first column we have to omit it, we have to ignore, and then finally we have to write other 4 result 4 3 3 4. So that means we have to write this one 4 3 3 4. Is it clear? This one is the process. Then next one is plus of. Now here you see in this case, second thing, if you consider suppose this element 3, second time if you consider the element 3, what is the position of this 3? First row second column. So that's why here we have to write minus 1 to the power 1 2, so that means here we have to write 1 plus of 2, and the element is what here, 3, so that's why we have to write 3. And then if we ignore this second column and first row, then this row column cancel, so what will remain here, 1 3 1 4, so that's why here we have to write 1 3 1 4. Is it clear? This one is the process. Plus the last one is, now in this case the third position, what is the position of this element? So here first row third column, so that's why here we have to write minus 1 to the power first row third column, isn't it? And the element is what here, element is 3, and the third column and the first row we have to ignore, so what will remain here, 1 4 1 3, so that's why here we have to write 1 4 1 3. This one is the process to write, to evaluate a determinant. Later on, no need to write minus 1 to the power 1 plus 1 like in this way. Directly you can write, if the position, if we start a determinant from here, the first row first column, isn't it? So if we start from here, suppose we can evaluate from here also, so what is the position of this one, third row first column, isn't it? If we start from here, so here this one is second row first column, so second row first column, what is the position, 2 1, so in this place minus 1 to the power 2 plus 1, in this way we have to write. So only for that reason here the first one we apply here the first row, that way here this one is plus minus then plus, that's why we get here plus minus plus. So if we evaluate this one, so now here you see minus 1 to the power 1 plus 1 positive, so 4 4 16, 16 minus here 9, so that means this one remain here 7. So second one is minus 1 to the power 1 plus 3 1 plus 2, that means negative 1, so that's why we have to write minus. So here what we write, 1 into 4 4 4 minus 3 1, so ultimately here remain minus 3. Is it clear? And if you evaluate like in this way, so minus 1 to the power 1 plus 3 positive, but here if you see 1 into 3 3 minus 4 minus 1, so minus 1 into 3, ultimately minus 3. So that means here 7 minus 6, this result we get here 1. So that means this result is not equal to 0. So determinant of A value is not equal to 0. If determinant of A is not equal to 0, then this matrix is known as, this square matrix is known as what? A non-singular matrix. Is it clear? Because the determinant of A value is not equal to 0. Clear? Now the next part here, after finding the determinant, next we have to find out the adjoint of A. So in this case, how can we find out the adjoint of A? Here you see now first. So for adjoint of A, we need the cofactor. So cofactor of each and every element, isn't it? So that's why here, first of all, now if you find out the cofactor of the first element, A11, so A11, so here the first row first column, this one, so what is the formula? Minus 1 to the power, so the formula is minus 1 to the power 1 plus 1 into M11, isn't it? M11 means what? The minor. So for this element, if we ignore this first row first column, then here remain 4 3 3 4. So that's why here we have to write this one is minus 1 to the power 1 plus 1 means positive. So this one we have to write 4 3 3 4, this one we have to write, and then if we evaluate this one, we get here 7 4 4 16 minus 3. So in this we to evaluate the other results also. So now the next one is, if we write the second one, A12, so here we directly write now, let's see here, for 1 2, what is the position here? This one is 1 2, for 1 2 here minus 1 to the power 1 plus 2, that means negative 1. So if we take for this one, already evaluate here, you see this one, isn't it? So what we get here, this one we get here, first row omit, this second column omit, so here 1 into 4 4 4 minus 1 into 3, 4 minus 3, isn't it? So this one we get here 4 minus 3, here 1, and already minus sign is there, so we can directly write here minus 1. All of you understood this one? All of you understood? A12 equal to, here we get this one is minus 1, isn't it? Similarly, if we evaluate the third one, A13, so I write here A13, so A13, if you calculate this one, here also again we get the same result here, minus 1. You see 13 is this one, so ignore this first row third column, so what we get here, 1 into 3 3, 1 minus 1 into 4 minus, so because 1 3 position, 1 plus 3 positive, so that's why here we get minus sign. So this one is about the cofactors of the first row, isn't it? Similarly, here we have to find out the second row, 8 2 1. Second row is here, we have first one, we have to find out 2 1. So in this case, now let's see what we get here. A21. A21 equals to, here we get, if you see, for this element we have to evaluate. For this element we have to evaluate. So this row, this column we cancel. 3 4s are 12 minus 3 3s are 9. So 12 minus 9 here. And here the sign is what we get. 2 plus 1, that means minus. So minus this one we get 12 minus 9. Ultimately here we get the answer is minus 3. Is it clear? Okay. Next one is here we have to find out A22. In this way you have to find out A22. So A22 means which element? This element. This row, this column cancel. So what will remain? 2 2 means minus 1 to the power 2 plus 2 positive. So 1 into 4 minus 1 into 3. That means 4 minus 3. So in this case here we get this one is 4 minus 3. That means the answer is 1. And finally here A23. So in this way if we evaluate A23, then the answer you get here 0. So A23 equal to 0 you get. Is it clear? So in this way you have to find out A31. In this way you have to find out A32. And in this way you have to find out A33. So in this way you have to find out A31. 31 for third row, first column, isn't it? So in this case we get here minus 3. So this result we get here minus 3. This one is 0 and this one is 1. Easily you can evaluate like in this way. So these are the results of cofactors. So next we have to find out adjoint of A. So now if you find out the adjoint of A, therefore here you have to write adjoint of A. So adjoint of A equals to, you have to write on the cofactor. So cofactor means here you have to write A11, this one we write A12, this one we write A13. Second one A21, this one we write A22, and this one we write A23. Similarly here A31, this one is A32, and this one is A33. And if we transpose this result, because here when we have to find out adjoint, first of all we have to write down all the cofactors and then we have to transpose this result, isn't it? So that's why here simply written transpose T, or sometimes you can write this one like in this way also, transpose of all the cofactors you can write. So each and every value if you put here, so already we find out this A11, 1, 2, 1, 3. So 1 1 is what? 7, 1 2 is what? minus 1, and 1 3 is what? minus 1. So if these results are, if we put here minus 1, minus 1, minus 1, second one is minus 3, 1, 0, and the last one is minus 3, 0, and then 1. These are the results, and this result we have to transpose. And if you transpose this result, finally we get, transpose means what? Interchanging of row and column, isn't it? So here what you have to write, the first row 7 minus 1 minus 1, then the second row minus 3, this one is 1, here it is 0, and the third one we have to write here minus 3, 0, 1. So after transposing the result we get like in this way. Let's check out one more time. So here the first row we get here 7 minus 3 minus 3, then the second row is minus 1 1 0, and the last one is minus 1 0 1. So I hope all of you understood this one, how to find out adjoint of A. So after finding the determinant of A and adjoint of A, now we have to verify this result. So this result you have to verify by yourself. So first of all what you have to do, adjoint of A already we get, and A matrix is we know here. So what you have to do, taking left hand side and just you have to multiply these two results. So that means this matrix we have to multiply with this. So matrix multiplication all of you know. After multiplying these two, if you see the result you get there, if you multiply these two results, then we get identity matrix after multiplying. So in place of identity matrix, we can write 1 into identity matrix. So 1 means what? 1 means what? Determinant of A. So that's 1 equals to, we write determinant of A equal to I, which one is equal to right hand side we write. Is it clear? Okay, next part is A inverse. We have to find out A inverse. So what is the formula of A inverse? A inverse equal to 1 by determinant of A into adjoint of A. So 1 by determinant of A, in place of determinant of A we have to put this value, and adjoint of A means we have to put this value, and 1 into this result. Ultimately here the A inverse value we get this one. What we get? 7 minus 3 minus 3, minus 1 1 0, minus 1 0 1. So in this way we have to solve this type of question. I hope all of you understood this one. So this one is using formula we find out the inverse. So in our next class we have to solve some algebraic question. Is it clear? Okay, thank you.